In a geometric sequence, the ratio between consecutive terms stays the same all the time. So if I divide consecutive terms, I'll get the same number every time. For example, this is a geometric sequence that we see here. If I do 10 divided by 5, that's 2. 20 divided by 10, also 2. 40 divided by 20, still 2. So this is a geometric sequence. Another way to look at a geometric sequence is to go from one term to the next. I'm going to multiply by the same number every time. So if you notice, 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40, and that ratio 2 is the thing that we're multiplying by. So in a geometric sequence, we have a common ratio, and we're going to call it R. We can write a recursive definition for a geometric sequence. This is going to say, to get to the next term, I'm going to multiply the previous term by the common ratio, because that's what we're doing. We're just multiplying by that same number over and over. So to get to the next term, I'm going to take the previous term, which is the n minus first term, and I'm going to multiply it by the common ratio. For a general term, or an explicit definition of a geometric sequence, well, let's see. I'm going to take, to get my nth term, the general term, I have to know where I'm starting from. I need to know what the first term was, a1, because if my value of n is 1, if I want just a1, I have to be able to know what that is. So I'm going to start from a1. To get the second term, then, I would multiply by the common ratio r once. To get the third term, I'd multiply that by the common ratio r for a total of twice. To get the fourth term, I'd multiply that again by the common ratio of r. Now I've multiplied by r 3 times. So I'm multiplying by r over and over, which I can write as an exponent, and I'll multiply 1 less than the number of times that I want for the term that I want to be at, so r to the n minus 1 power. Let's look at this particular example here of a geometric sequence. The common ratio here, r, we already noticed was 2, because I'm multiplying each term by 2 to get to the next one. So the value of r for this geometric sequence is 2. For a recursive definition for this sequence, the nth term, I'm going to take the previous term, the n minus first term, and multiply it by 2. That's all there is to that. To get the next term, multiply the previous one by the common ratio, which is 2 here. For a general term, I'm going to need to know where I started from. That's the a1 is the first term in the sequence. For this sequence, that's 5 times my common ratio r, which is 2. We set that up above there. 2 to the, well, if I want the nth term, I'm going to multiply by the common ratio n minus 1 times. So there's my general term for this particular geometric sequence. If I want to find, say, let's see, I don't want to go too high here because the terms of a geometric sequence tend to grow pretty fast. So let's do a8. If I want the 8th term of this sequence, okay, it might not be that strenuous just to multiply by 2 3 more times, but we're going to use the general formula. A8 is, I'm still starting from 5. I'm going to multiply that by my common ratio, which is 2 to the n minus 1. Well, n is 8 because I want the 8th term. So n minus 1, 8 minus 1 is 7. Now we have to count. 2 to the 7th power, 2, 4, 8, 16, 32. Yes, I am using my finger. 64, 128. 128 times 5. Whatever that is. That's the nth term of, or the 8th term of this geometric sequence.